Alright, let's talk about ionic compounds. For the most part, what will qualify a compound as being ionic is the presence of a metal at the beginning of the structure. If you have a metal combined with a non-metal, you very likely have an ionic compound. There's only one real exception to this, and it is if instead of having a metal, you have NH4. Having NH4 or metal at the beginning of your formula implies that the compound will be ionic, but for the most part, metal plus non-metal, those are your ionic compounds. So you gotta recognize the division right here. Right to the left, you have your metals, except for hydrogen, and to the right, you have your non-metals. And if you combine one with the other, you have your ionic compound. Now, the better definition, though, to look at this is to think about something in terms of, or think about this in terms of having a positively portion and a negatively charged portion. We refer to them as cations and anions. And the ionic compound, by and large, the way we think of them is that the reason they're put together is because they have these positive and negative charges attracting each other. But there's nothing in terms of electrons binding them one to the other. It's just fully a charge to charge interaction. But you're going to start with the cations, and in order to really be able to name these things properly, there's one extra thing that I have to tell you in respect to the metals in particular. There are certain groups in the periodic table that the charge of the element, once you mix it with some other element, will develop the charge associated with its group number. So the group 1 elements, if you combine them with any other element, they're going to have the +1 charge. The group 2 elements, if combined with any other element, will have the 2+ charge. The group 3 to a great portion will also have the +3 charge if combined with some other element. In addition to that, oxygen and fluorine will only have one charge really. Oxygen will be 2- pretty much, and fluoride will be 1- if combined with some other element. For the metals, zinc, cadmium, and silver 1+. Those are the only real charges of those elements. So I need you to memorize that zinc will be 2+, cadmium will be 2+, and silver will be 1+ if combined with some other element. After that, what you have to pay attention to is the elements that have dual charges as possibilities. Iron, cobalt, and nickel could either be 2+ or 3+. It'll be important to remember that because it'll help you narrow down on the actual charge when you're dealing with the structure. Copper and mercury could either be +1 or +2. Palladium, platinum, tin, and lead can either be 2+ or 4+. And then you have gold that could be 1+ or 3+. So those are the ones that have dual charges as possibilities. Any other element in here that I didn't really highlight, I didn't highlight it because they have a high number of possibilities for their charges, and you will have to actually do a little bit of math to figure out what the charge is. But the ones that I highlighted, group 1, 2, 3, oxygen, fluorine, zinc, cadmium, and silver, I need you to remember the charges for those particular elements. They will only have one charge. It's either going to be the group number charge or the charge that I'm highlighting here in the actual PowerPoint. Alright, so much like the molecular compounds, ionic can be subdivided into binary and polyatomic. Let's talk about the binary first. Alright, because the compound is binary, we're going to have to end it with the suffix IDE. In fact, the fact that we will be using IDE in the name automatically tells me and anybody else that the compound has to be binary. If you use a suffix other than IDE, then you're telling me that the compound is not binary. The only one exception being the binary assets that use the prefix hydro to tell the reader that the compound is binary. But alright, so we're going to first name the cation, which is usually going to be a metal. And if it so happens that the metal can have more than one charge as a possibility, you're going to have to specify the charge with Roman numerals after the name of the cation. Then you name the anion and you end it with the suffix IDE. Now there's another way of going about it. If you are dealing with metals with only two possibilities for the charges, the higher charge can be depicted with the suffix "ic", and the lower charge can be depicted with the suffix "ous". But you have to use for some of them the Latin names. Now, specifically, the elements that I'm highlighting here in yellow are the ones that have dual charges. Iron, cobalt, nickel, 2 plus, 3 plus. Copper, mercury, 1 plus, 2 plus. Palladium, platinum, gold, palladium, platinum, tin, and lead, 2 plus and 4 plus, and gold, 1 plus and 3 plus. Silver, I just want you to forget about the 2 plus. It does exist, but it's very rarely encountered. So for all intents and purposes, silver only has the +1 charge. Alright, now for some of these elements, you could use the suffix "ic" and "ous", like for cobalt. If you were dealing with a 3 plus charge, you could call it cobaltic. If you were dealing with a 2 plus charge, you could call it cobaltous. But some of these elements, especially the ones for which the name of the element doesn't line up very well with the symbol of the element, that's because they have Latin names. And in terms of using the "ic" and "ous" ending, you're going to have to use the Latin name. So iron, if you are to use "ic" and "ous", you have to call it ferric or ferrous. If you're going to use copper, and you decide to go with the "ic" and "ous" ending for the metal to specify the charge, you will have to use the Latin name. So this will be cupric and cuprous. Now, as I mentioned, silver, I'm not going to have you go with multiple charges, so you don't have to worry about silver. But for gold, you do. If you're dealing with a higher charge and you want to go with the "ic" and "ous" endings, you're going to have to call it auric or aurus, basically using the Latin names. And for tin, if you want to use the higher charge and lower charge, you're going to have to call it stanic or stanis. And notice the two N's in the name. For PB, you will have to use plumbic or plumbus to specify the charges. Now, this is one way to go about it, and you need not use this way to name the elements, but you kind of need to be aware of in case I decide to name some of them this way, so you know what I'm talking about. But you could just use the Roman numerals instead of the Latin names with the "ic", "ous" ending. So this is kind of a preference in some ways. Alright, so to give you an example, I'm going to give you a name and we're going to derive the structure from this name. Alright, we're dealing with Lec4 sulfide. Notice that I have the Roman numeral 4. Automatically, the Roman numeral tells me the charge of the element, meaning that lead has to be 4 plus. The IDE tells me that all you have here is lead and sulfur. There's no other elements. You can only have two different kinds of elements because the compound is meant to be binary as a result of the ending being IDE. Alright, now also I could have called this thing plumbic sulfide and it would have been the same thing. The difference is that in that case you would have had to recall the charge of lead, as being 2 plus or 4 plus. Alright, now to figure out the charge of sulfur, you use a formula very similar to the one we use for determining the hydrogen content in oxyacids. You're going to subtract 8 from the group number of the anion. And this number will always end up being negative. In the case of sulfur, the group number is 6. We can see that here, the sulfur group number is 6. So 6 minus 8 tells you that the charge of sulfur is minus 2. And now all you do is you cross multiply the charges. Bring the 4 in front of the sulfur, bring the 2 in front of the lead. Yes, cross multiply them to come up with a structure. And at the very end, all you have to do is go with the lowest ratio. You can actually divide both of these numbers by 2, and if you do that, you're going to end up with the following structure, PbS2. This is Lec4 sulfide, also known as plumbic sulfide. Alright, in the next video, I will describe to you how to name polyatomic ionic compounds.